Next up is Vertex AI. Vertex AI is GCP's platform for machine learning operations, or ML ops. It provides tools to handle the entire ML workflow, from data preparation to model training, deployment, and ongoing monitoring. Instead of using separate services for each of these tasks, Vertex AI consolidates them into a single platform, and that makes it easier to manage ML projects, especially at scale. It supports both pre-trained models and custom models. So whether you need an out-of-the-box solution for common use cases or you want to build something entirely from scratch, Vertex AI provides the flexibility to do both. You don't need to know many of the details about Vertex AI for this exam, but you should know generally what it does. And you should know about Vertex Explainable AI. So this is a feature of Vertex AI that helps to make machine learning models more transparent by providing insights into how they arrive at their predictions. Without this kind of visibility, sometimes ML models can act like black boxes, and that makes it difficult to understand why they classify or predict things the way they do. And clients and customers can sometimes have trouble trusting the predictions of ML models as a result if they don't have this explainability. And honestly, rightly so. Explainability helps to build trust in model outputs, and it can highlight potential issues with training data. So it's super important. There are two different ways to approach explainability in Vertex Explainable AI. One is feature-based explanations, which help to break down the contribution of different factors in a model's prediction. In this bar chart, we see a model predicting delivery duration, and each feature, like traffic congestion, delivery distance, and time of day, has an attribution value. The longer the bar, the more that particular feature influenced the prediction. And so this shows or tries to explain how the model arrived at its predictions. This approach is useful, especially when working with structured data, and helps to identify which factors are driving outcomes. And then we've got example-based explanations, which take a bit of a different approach by comparing an input to similar data points that the model has seen before. So in this case, we've got an image of a bird, and it was incorrectly classified as a plane. Now, the issue that we can see here is that the model is relying on shape alone. It's relying on this silhouette shape of the bird, and it is thinking that it resembles the silhouettes of planes in the training data. Those are the examples that it shows. So what this tells us, and this is why it's so useful to use explainable AI, so what this suggests is that the model might need more examples of bird silhouettes in order to be able to distinguish them from plane silhouettes, and therefore not incorrectly identify the bird as a plane. So these kinds of insights can help teams refine their models, adjust training data, improve accuracy. It could show up on the exam. It's not going to be a main thing by any means, but it is good to understand how explainability works in GCP and in Vertex AI specifically. All right, that's what you need to know about Vertex AI for the exam.